Okay, this panel is going to continue the discussion of the relationship between the lunar base, the lunar infrastructure, and the lunar and what I call the cislunar space transportation system and the logistics system necessary to get the equipment and the people onto the lunar surface to support that lunar base, and where some of the things have gone right and where some of the things have gone wrong. So I'd like to ask the panel members here to each give about a 3-minute talk, whatever they think is the most important issue that's currently facing this whole issue of the lunar transportation and the logistics problem. And Seth, you want to start?
Yeah, I would start by saying that I agree with a lot of the ideas that you've had, John, in that there's certain opportunities with the VSE. There's certain things that maybe could be done better. I tend to be a little more optimistic in that I think that we'd all like to see a sustained presence on the moon, not just a rehash of Apollo. Part of that sustained presence is in situ resource utilization. I don't think that that's been locked out of the current VSE. It's not there. I don't think it's totally precluded. The other thing is I'm an agnostic as when it comes to lots of little boosters or huge heavy lift. As long as the flight rate is high, and in the long run, as long as the overall program cost is low, pays to develop heavy lift capability if you're going to get enough uses out of it. And it seems to me in sustained lunar presence where you have something like 2 to 4 flights a year, you probably would.
Let me make a quick response to that. The critical two things with the heavy lift issue, and there's two of them primarily, is in the size of the minimum habitat module that you need to land on the lunar surface. And some people are talking about very small HAB modules, maybe less than 10 tons. Typical space station module, HAB modules, maybe more like 20 tons. To land a 20-ton module on the lunar surface, you need a certain size of lunar lander. To get that lunar lander into the lunar orbit, you need a certain amount of fuel. So what I call this back calculating, you calculate back from what you need on the lunar surface to the payload that you need to get it there, and then to the rocket size you need to get it into orbit. And it seems that you really need something like a minimum of 100 tons or more to get that size of payload up. And also, the other issue is for the Mars program, of course we don't need it right away, but to operate a Mars program, you're going to have vehicles with an integral aero shell. The entire module, the entire vehicle will not be one that you can assemble easily in orbit from pieces, like some of the current spacecraft stacks we used with Apollo, because that whole object, which may be 100 tons or more in weight, is going to have to descend through the Martian atmosphere if it's going to take off again, or even if it's going to get to the surface in one piece. And there's on the Mars track a discussion this weekend about the difficulties of landing heavy objects on Mars, which I think is a very significant talk. We need to pay attention to that. So because of that reason, you need to launch eventually large integral objects into space. And that's why I support HLVs.
John, I need to make one or two administrative points. One is the views I state are mine and not necessarily those of my employer. Or as somebody once said, the opinions I'm expressing are mine, nobody else wants them. So that's about it.
Go ahead.
Yeah, I'm Carlton Rhodes, retired aerospace engineer, and I've done quite a few things in aerospace that were fun, enjoyable, and accomplished something for me, and not only me, but for my employer. I worked at Boeing about half of my career. I worked on Boeing commercial airplanes. I spent 7 years in the Boeing wind tunnel. The last 10 years of my career was spent working with software, analytically. Is it good software, whatever good happens to be defined as? And but Today, we're talking about going back to the moon. And I have ideas on why we should be going there, what we should be doing there, and I came here, and what you're going to hear on Sunday is sort of an outline of another chapter in a book that I'm writing, and it's on the heavy lifter.
Uh-huh.
Heavy hauler, I call it. And its purpose in life is to be a first stage. About 1,000 of them would burn up the same amount of energy as one shuttle launch. Getting to launch to the second stage, which would go to low Earth orbit. And the second stage would be, it'd be a couple of hundred tons. Well, make it 100 tons. And I think that falls in the ballpark you were looking for, John.
Right.
And then once we get there, now it gets serious. And we don't know anything about the moon and working there and doing anything useful. Haven't been there. A few people have been there, and the first mission to the moon, its job is to bring one of those lunar rovers back so we'll know how many miles are left in it, if any. We've all seen them in use, and man, they were brutally used. And how are the bearings? Are they worthless after that? Because that lunar soil is highly abrasive, gets into everything. And it's something we don't know how to work in. But I know that there are so many things we have to learn how to do some simple tasks. We have to know how to generate electrical power. We have to know how to, and that's for doing the simple tasks, and also for communicating back what we found and receiving commands from Earth. And then we have to have some sort of accommodations for those who are going to be there, who have to service everything. And looking at that Shackleton crater, and I said, is that what's there? I couldn't believe it. I really haven't read much on it. I was aware that they were going to do it, but it doesn't make sense. It looks to me as if they are picking probably the worst place. There's a lot of level ground out there, and that's where they're going to be building things. They're not going to be landing there.
You mean on the crater rim?
On the crater rim.
Okay. That crater rim image, I might be able to even go back to it here if I can zoom up to it. There we go. I got it there.
Yeah.
This is the crater rim of Shackleton Crater. The pole is the orange cross on the right side. It's very close to the pole, and the reason for this location, the areas that they're showing there are relatively level. The areas outside of that curbing zone are sloping because it is part of a crater, obviously. And the reason they want this crater rim is because the areas are illuminated most of the time rather than only half of the time, and they're illuminated much more frequently than like every 2 weeks, like an area along the equator of the moon is. So this makes it a lot easier to survive there. Several people have suggested that maybe we should do a much tougher first lunar base, building one on the equator of the moon or near the equator, where there are greater varieties of mineral resources. But you will need a much more robust power system with multiple backups, because if you lose your power in the middle of the lunar night, you're dead. So it's a significant, serious problem. The only other question is perhaps burying the modules, which we're going to get to in a minute. But did you have any more comments on that?
Well, I don't want to monopolize the time.
Let's go to Wayne.
Okay, thank you. I've got a quick briefing here.
Okay, great.
If we can pull it up. The basic discussion topic is really two topics for the panel. I was asked to talk for just a few minutes on it. Discussing primarily the current NASA lunar plans, their good and bad points, the alternative methods of the transport system, and then the lunar activity. So the transport system and the lunar activity are the two main topics. The plans, you know, if you want to just summarize NASA's plans, basically it's retire the shuttle in 2010, complete the International Space Station, develop a new crew capsule, evolve or develop a new crew rocket, the Ares 1, develop a cargo rocket, the Ares 5, that's a heavy lifter, go back to the moon and then Mars, and apply what you learned from the moon to Mars. Those are the basic transport plans in a nutshell, and if we look at that transport system for that, it has many appealing features. If you look at Ares 1 and Ares 5, they've got the separation of crew and cargo. There's no sense having people on board if you don't need to. So you've got a heavy lifter for cargo and a customized vehicle for crew or lightweight cargo. Your high-value crew and your cargo are at vehicle top dead center. Okay, I think that's very important. They're in the shadow of the launch vehicle structure. They're far from the acoustic sources, so you have a better ride. And the heat shield is encapsulated during ascent. Okay, if you look at any side mount, like the shuttle, okay, you're down there close to the rotating engines, you're close to the acoustic generation, you're more susceptible to flying object debris, and your heat shield is exposed during ascent. You could hit a bird. You could get a chunk of ice fall off. With the heat shield encapsulated within the fairing of the stage below at launch, you could hit a bird on the way up and it would not be catastrophic to your heat shield. The last point there is it's not too reusable. I think points have been made in the last hour. You don't want expendable vehicles, you want reusable vehicles. Well, let me go over my comment of it's not too reusable. The orbiter for the space shuttle really became obsolete before it became worn out.
That's right.
Yes, the right flyer, okay? We don't throw away our aircraft, but on the other hand, we're not trying to fly a modified Wright Flyer anymore either. We do, in fact, throw away our aircraft, lots of military aircraft, especially in the early stages. So, and the space shuttle, because it was designed for 100 flights over for 10 years and really operated for 25 years, and none of the orbiters are approaching their 100 flights, the calendar time period on those is such that some of the design intent's been lost. It's very hard to replace parts with new upgraded parts or new computer parts because you're not sure exactly if the clock speed is going to screw something up. And upgrades became impossible in some areas. Contrast that with the solid rocket boosters that were forced to evolve to the reusable solid rocket motors and are now becoming the CLV 5-segment booster. They have limited life. They had opportunities for upgrade along the way. Contrast that with the external tank, which is a new external tank each time, has evolved to lighter and lighter weight tanks and will now be the core vehicle for the CALV, the heavy vehicle. And with the CEV, the new capsule, what I've heard would be good for like six flights or something like that, but not 100. Okay, so that chances are about the time in the calendar period, 4 or 5 years later, when it's starting to approach the end of its flight life, it'll be time for a new capsule anyway, and the design and the manufacturing systems will allow you to incorporate the upgrades you would like to. If you don't want the computer you had 3 or 4 years ago, you want a new computer. You got tired of upgrading it, and this allows us to do the same thing with the capsule. So, and it allows all the major components to evolve over the life of the program. Another comment was made, this may not be the heavy lifter we want. Well, that's not the heavy lifter we have yet, okay? And I submit that the heavy lifter that actually gets developed seriously, you know, when they start really serious development of the heavy lifter in 5 or 6 or 7 years, it will be a little bit different than that. Hopefully. And we will continue to learn and evolve the components as we go. Some comments on lunar activity. What's interesting about the lunar activity this time is it's not a race to put the first human on the moon. The objective is for an extended or permanent exploration presence, and learn from that to apply it to go to Mars. This is a substantial new undertaking, okay? And the undertaking, one of the big thoughts here is understanding the extent of the lunar infrastructure required for an extended presence, and think about how we want to create that infrastructure, because there's a tremendous amount of infrastructure that's required for human presence for an extended period. And a related question to that is, do the humans arrive first and bring everything with them, or do humans arrive last after you've created the infrastructure with robotics? Or do they arrive pre or post infrastructure, and which of these is more flexible and evolvable? Which will allow the greatest flexibility and ability to meet the extended exploration needs? What will we learn most about for Mars? An extensive infrastructure is required to support humans there. Okay? We've done some analyses. If you look at the life support, the power, the radiation shielding, all these, and then the interactions of what the humans interact with, how they want to go and do some exploration here, the transportation systems. There is just a lot there, and if you want to start off with the human presence, you have to take an awful lot with you. I think we've demonstrated on Mars with the rovers that for remote operated machines, you have a lot less infrastructure required to support them. So you could land some robotic machines there, and they could be sent years ahead of the people and prepare some of the infrastructure for eventual humans to occupy safely. They could build remote operated machines, just like the rovers on Mars. They moved a cubic foot a day. In a couple of years, you'd have moved 700 cubic feet. You could build some of the radiation shielding structures, and then when the people arrive, maybe you don't send people until there's a critical mass of prepared, or a threshold amount of prepared infrastructure already there. Along with that, you think about the type of missions and how much mass is involved. We've heard about the heavy lift missions. Obviously, if each exploration site is individually outfitted with some sort of short-term infrastructure brought from the Earth, those are numerous mass-intensive missions to go to the moon, all requiring these heavy lifters. And you've got a lot to take with you, and then you leave a lot of it there because you want to go to another spot next time. If you have a single permanent presence site outfitted with a comprehensive infrastructure you bring from the Earth, and then go away for a week or two at a time to different locations on the moon from a central spot, maybe that's at one of the poles at Shackleton Crater, maybe that's someplace else, then you still have the big heavy lift missions to get there, but fewer of the heavy lift, then you're transporting the people each time, a little bit each time. And if you really want to dramatically reduce the mass that you have to take, one of the thoughts is, if you can use remote operated machines, like we're doing with exploring Mars right now, to build or fabricate some on-site infrastructure using the in-situ resources, starting years before the people arrive, then the mass you have to take is much reduced, and before people even get there, much of their safety is already assured because it's already been built. Those were the primary thoughts I had, just to get people thinking and ask questions.
Excellent.
Thank you. Let's see, we want to go back to your presentation.
Well, it doesn't matter at the moment.
Okay, whatever you want to do.
Okay, let's see. Would you like to?
Well, I just presented before, so I think maybe it's time to let the audience start.
Let me just ask a couple more of these. I had a list of questions. How far are we along in the time? Okay. Let me go for about 10 minutes on questions, and then the remaining time I'll let the audience ask questions. But I sort of wanted to get the panel's opinion on some of these specific issues that I have brought up. And I guess the The biggest one that we haven't really addressed as much is your impression of the issue of the reusable versus expendable lunar lander, because whereas the booster reusability is not as critical to the crew, and they are doing a good job of designing the Ares 5. I have no objections. In fact, I would love to see an Ares 5 take off. At the same time, I realize I think it's a big mistake. So I have a sort of a split personality there. But when you talk about the lunar lander, an expendable lunar lander is basically the same as the original LEMs back in the Apollo days. And when my dad's rocket engine, his company's rocket engine, took the astronauts off the lunar surface, if that rocket engine had failed, or if the guidance system of that vehicle had failed, they were dead, because you can't bail out. There's no backup system to save them, like there is in a jet aircraft where you can pull your D-ring and bail out. There's just nothing you can do. Whereas if the whole lunar lander or lunar ferry takes off with its crew cabin, and then there's a failure, then that crew cabin is redundant, and it can either go back and land at the landing site, or it can go push on and go back into lunar orbit. So you have two chances of living instead of just one. And over the period of lunar operations that I see at this lunar base, you're liable to have several deadly accidents because of just the normal rate of failure when you're having large numbers of missions. You had like 6 landings on the moon, and we were really lucky that all those crews got back alive. Very, very lucky, considering how many things could go wrong. So just the opinion of each panelist, what do you think of the concept of either designing the lunar landers to be reusable from the beginning and separating the cargo from the crew so that the entire mass of cargo is instead turned over to fuel to get back into lunar orbit, which could also be, of course, produced from the lunar surface versus the current expendable mode. Go ahead, Seth.
I basically do, of course, I like the idea of reusability. The original vision for space exploration used the term safe haven a lot. That is,
yes,
at each stage of the trip, low Earth orbit, translunar phase, lunar orbit, lunar surface, there should be a place for the astronauts to take refuge if something goes wrong, either with the equipment or solar flare or something. It's kind of not very useful to have a safe haven if you don't have any way of getting there. Now, having said that, John, I agree with your architecture, but we need to subject it to trades.
That's right.
It depends on the capacity of the crew module and the lunar lander. Depends on how much fuel they have.
Right.
You may have enough air and supplies for the astronauts to survive a trip, but if the size of the tank, and you may have a gazillion tons of fuel in a depot on the surface or in lunar orbit, but if the tanks aren't big enough, and if making the tanks big enough to hold all that fuel necessary for the abort means that the vehicle is unfeasibly large, it's not going to work. The example I like to cite is, and I don't actually have the exact numbers on it, but people look back at Apollo 10. They came within, I think, 10 miles of the lunar surface.
Right.
And the question is, why didn't they just go down and call that the first lunar landing? And it's not just a question of the reliability of the engines, but once you touch down on the lunar surface and you cast your fate to the surface of a rotating planetary body, if you're there for more than a few hours, you're rotating out of the plane of orbit of the command module. It's going to take you a lot more fuel to get back. I don't know if they had it or not. I suspect they did not. So all these are issues. So basically, if it's feasible, if the vehicle is not intractably large, then of course I'm for it. And we take a comment, I think.
Information on
Yeah.
that I heard recently on NASA retrospective on the Apollo program. The crew of Apollo 10 was being interviewed, and they said to make sure we understood we were not to land, only the ascent stage of that lander was fueled. So they did not have any fuel on the descent stage to land if they wanted to.
Good point. That is the vehicle. In this case, the vehicle.
The capacity. I just
Apollo
want.
11, Apollo 10's lunar module was too heavy to land on.
Oh, okay, then that's new, then it didn't have the capacity. I was just making the point that when we design future lunar landers, if we want this abort to safe haven capability, we need to study the feasibility of that, that's all.
In the presentation I did last year, where since I'm not an engineer, I simply use ratios instead of actual engineering calculations to estimate the sizes. And I estimated that the vehicle that would be a crew lander with only minimal cargo, with a reusable, fully reusable with a crew capsule on top of it, would be only slightly heavier than a lander which included a crew cabin and a hab unit on board parallel to the crew cabin, which I consider rather dangerous. And I consider all of the hab units should be landed separately on basically flatbed landers. When you take the cab unit off the lander, there's no payload at all on it. It's just basically a lander stage, and with only very small extra amount of fuel, you can get back into lunar orbit because there's nothing on top of it. It's much, much lighter. Okay, Carlton.
Yeah, okay. Robotics, and somehow or another that has a bad name. But it's the first thing we send there, because the robots, we don't have to worry about safe havens. We don't have to worry about a place to get in and out of the weather, none of that sort of thing. And they're probably could be designed to go back and retrieve that rover. And they're also the ones who would find out first thing out away from Shackleton Crater, just how easy that terrain is to work. How easy is it to dig? And it probably would be very easy if you brought, say, 100 yards of it down here onto the surface of the earth somehow and sent some equipment at it, little tiny bulldozers and ditch diggers and all of that other equipment which you will need when you're putting your self-installations in. And those can be done robotically. You can build them. People have built them. There are some good examples of it on display here, where people have made some attempts at it, and I've seen some more sophisticated attempts at doing this, where you send them out, they send their little tools, little robots out into a sandbox and show you how they can dig holes and do all their other nice little things. But it's a different environment, and it's a highly abrasive material you're working with, and you don't know what's under the surface. I don't recall seeing one astronaut with a spade.
Actually, they did dig when they found that.
Right.
Remember the orange soil? I think they did some digging in that site.
Yeah, that one site, they had this little tiny,
Yeah.
spade.
They had core materials,
Yeah, and then they
I
had the
think they did a
core,
few
right.
cores, right.
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 And they try to do that. But you need to have something, if you have a robot that will, and since you are probably going to be solar powered, you dig like fury when the sun is up and just rest, let it regain itself.
So you have a nuclear power system.
Okay, if you have a nuclear powered little bulldozer or whatnot, you'd work it like the devil all the time. And you have it gathering data for you. And if it looks like it's a workable area, that's probably an area you want to think of going first in order to do this. And the other one, let's see, it seems to me that the Saturn last stage booster, they all went up with
The S4B stage, you mean?
S4B, yeah. And I think that they were supposed to fall on the moon.
One of them was.
They're starting on Apollo 13.
Yeah.
Apollo 13.
They did
yeah,
that
13.
to try to get the impact shock for the sensors. I
Right,
think.
right.
Yeah.
They'd set up the sensors by that time, so they knew when a body hit what they could hear or what they could sense of the fall.
Now, I fully agree with him on the significance of the issue of the lunar dust, because we found that it's very similar in some respects to volcanic ash, which consists of thousands of very tiny, jagged, glassy fragments from all the millions and billions of years of meteorite and asteroid impacts, which creates not just little round droplets of glass, but smashed fragments of glass. So it's like ground glass, but it's worse than ground glass because it hasn't been tumbled like in a stream. It's jagged. And so they need to really, and this is the thing I've been saying from the beginning, is in the robotic missions, they should be sending even possibly some pilot phase resource extraction equipment with like a little scoop that they can scoop some actual moon dust up in and put it into a hopper and actually try to process it on one of these robotic missions. Then when they get to the early missions of man, then they can have prototype scale equipment on those. And then when they get to the building the permanent base, then they would have full-scale equipment, and then you could go right ahead and produce lunar oxygen or whatever. So fairly quickly, maybe within 5 years after starting and building your base, you would actually have equipment on the moon significant enough to produce enough oxygen to take off again from, along with, of course, a lunar-based depot, which you have to store your fuel. But
the other one, of course, is if you want to generate fuel on the moon, you can use aluminum oxide, break it into its component parts, and when it comes back together again, you get a big energy release. And that's, and incidentally, that's what the boosters on the shuttle, that's in the
Right.
propellant in grand style. So
I think David had a comment here on that.
Yeah, there's a group called the Space Resources Roundtable, and I'll try and project so I can catch that mic. Dr. Larry Taylor at the University of Tennessee, Knoxville, has studied the fine-grained material of the lunar regolith, and over the billions of years of exposure, that even in the very finest, smallest particles, there has been an evolution and impact, and there's a layering. And so almost all of this material has nanophase iron in it. And Harrison Schmidt was commenting on the dust, and this has been much discussed to great length. But Larry was sitting there, and what he found is that almost all of this is magnetically maneuverable. And so, in fact, instead of being an overwhelming and impossible challenge, it may very well be that we can magnetically separate and filter this from at least the insides of the habitations, and maybe even around areas where it may be sensitive. It also fuses in a microwave very easily. So I would encourage you, for those of you who have an interest in lunar dust and the impacts, to take a look at the Space Resources Roundtable. I believe in their November 2nd conference proceedings, you'll see some papers by Dr. Larry Taylor, and I think co-authored with Harrison Schmidt. But there's been some significant work there, and they are also proposing a way to move this stuff, which would basically magnetically levitate it. So, this is just reinforcing your point that we have a lot to learn on the moon. We have the glorious history of the most wonderful, exciting camping trips, but it's a lot different when you have to live and sustain yourself there. And I guess my whole point in terms of being a critic of this vision is that if we're going to learn, we need to go there a lot. We need to go there quickly, frequently. We need to have a fast learning curve if we're really going to get the payoff. We need to have some sense of urgency about this and build on reclaim our Apollo heritage. We did a lot of orbital flights. We did a lot of lunar landers. We need to do the same thing again today. We also have to have a cost structure that's realistic. You talk about expendables. Well, if you have a tank, that tank has two purposes. One purpose is to contain the fuel that's going to take you to get up into space and around in space, but it also has a second use, and we need a cislunar architecture. So it has maybe a decades-long life serving as a gas tank. And there is no cislunar gas station network right now, so therefore you can't account for it, and you can't amortize it over the number of refillings and so forth. But there's a whole economic structure that needs to be accounted for in terms of why it makes sense to get it up there and to design them for this dual use. And we're going to have tanks all over the place. We're going to have to, if we're thinking about recapturing solar wind volatiles, for example, and these are at very low frequencies. People are always talking about helium-3, but of course we've got carbon and other solar, wind, and planet gases, and if we're going to harvest that, then we're going to need to separate it, and then we're going to need to store all of those gases. So when you think about it, we're going to need tanks, 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 tanks. And every time we go up there, we're going to need to be able to keep that tank and move that tank around and use that tank again and again and again over a long, useful life. Well, so therefore, the whole back part of that equation is not part of our cost accounting system today. We're making capital investments, but we should be making capital investments in the future on an absolutely certitude of that kind of infrastructure, and we've been neglecting it because we have a very limited vision. We have we have a lunar outpost. And a lunar outpost isn't even the same kind of anemic effort that was going on in Antarctica. Look at how much we've harvested scientifically from Antarctica, but we've chosen not to do anything economically with Antarctica. You know, we absolutely must do something economically with the moon, and we have to have a vigorous program of learning that requires a high flight rate. We have to have an economic system. Our balance sheet has got to be looking ahead at getting those commercial payoffs from oxygen and metals and vacuum manufacturing and all the things that can make a buck. And everybody is interested and understands what it means to make a buck. You know, I'm the generation that you know, they're worried about, we're going to run out of Social Security. The people who are in there, my son, 25 years old, doesn't think the Social Security system will exist. And you know, we need to make national investments that will allow my son and people who are going to need to retire the capability of having invested funds that are going to have a return on investment even nationally at that scale. There's a gentleman in back.
Yes, I'm looking at everything that's being proposed. You mentioned it, something right in there. That's infrastructure. We're missing part of our infrastructure. 1, navigations. 2, power. If we put a GPS type system on the moon, all our navigations, we can reduce the cost of all of it. Add into it communications in with it, we can completely communicate around the moon. And 3, power, placing a means of gathering solar energy, storing it, and using it for all these devices we want to put up there, where we can put a device up there, roll up to it, recharge, roll away. Another one come up, recharge, roll away, and just keep, instead of using nuclear energy and have to build a new nuclear plant for each single one. Have it all as reusable infrastructure.
I very strongly support you, and I strongly support David. Infrastructure is critical. We're going to have vehicles, tankers, cables, pipes, tanks, controls for all this stuff. And nobody seems to be discussing all this. You're going to have some way of managing where the fuel is stored, how you're going to manage the electricity. And if you're going to be at the lunar pole, the solar panels are going to have to be up in the air vertically like this. They can't be just laid flat in the ground. It was a number of years, I think Alan Wasser invented the lunar power tower, which was basically a tower with a rotating panel which rotated once every 28 days, and therefore always faced the sun. So another issue, getting back briefly to the dust, how about having a high-pressure water shower inside the airlock? You go in the airlock, the air blasts you after it comes in, and then the water blasts the remaining dust off. It goes down a drain into a filter, and it's all collected, and you walk into the main area completely free of dust. So there's a whole range of questions that need to be covered. Yes?
How about paper suits?
Then you have disposable paper suits, and the paper wouldn't last very long. What else would you like to ask?
Those who want to consider some of what we're saying in terms of infrastructure to come to the sessions that are coming up on Sunday afternoon on the lunar track, because we'll have a presentation by T.D. Lynn, who spent several decades learning how, and he knows how to make lunar concrete. We also have a team from the University of Arizona and Satellite Engineering who have a recycling system that's based on agriculture that's now in operation. It's not a paper study, but they built a greenhouse down in Antarctica and they also have a prototype now of a lunar module. They're going to be talking about it, and they are recycling, I think, per person, 136 liters a day per person that comes out of this greenhouse. So they're looking at the mass of reutilization and logistics, food production. All these things relate to the learning curve. And really, this is a species intelligence test. You know, we are learning to operate in a brand new, very brutal, tough environment. And unless we go up and start doing these things as fast as possible, we're not going to harvest the benefits of getting into this new environment. But our camping trip, we can't rest on our laurels. And a program that just repeats our camping trips twice a year, you know, it's a lot different to say, oh, I was up there for a few hours, and it's wonderful, and it's exciting to share that. But it really doesn't allow us to make the series of mistakes and to go up the learning curve so that we can continually evolve our technology and get better and better at it so that we can survive in that domain. And it's never going to be easier to learn than on the moon. I don't think that we have a wonderful opportunity.
Let Wayne make some more comments, and then we'll go back to the audience.
Okay, thank you, John. Getting back to John's original question, we brought up the problem of personnel leaving the moon and some of the risks associated with that. Separating crew and cargo, I think, is obviously always a good idea. You mentioned reusability as a way to improve the safety. What I think is intriguing with space vehicles, if you look at reusability or expendable, I mean, compare the space shuttle safety record to that of the Soyuz.
Right.
Okay, I'm not sure who would win.
Except remember, the space shuttle is not really a reusable, it's a refurbishable, reassemblable vehicle. And every time you reassemble it, in a sense, it's a new vehicle because you're not sure if all the plumbing has been reassembled correctly.
Okay. Okay.
That's the problem with
And
heavy
Yeah.
refurbishment.
and so I would think that actually any vehicle that's used enough on the moon would also need some extent of refurbishment.
And you'd only use them so many times. You'd use them
That's right.
5, 10, 15 times, and
Maybe-
then they'd be retired for a spare.
Maybe that's the solution. Maybe when you get to the point where it needs refurbishment, you retire it and rob it for spare parts.
You can do an engineering analysis where you can predict roughly, based on the component failure of the components in the system, how many times that vehicle would be reused before it's more dangerous than its very first untested flight, and at that point you then retire it.
Yeah, you go ask the people in the airline industry and the
Right.
FAA,
Yeah.
and they have their
They know how
A,
to
B,
do
and
it.
C checks,
Right.
and how much do you tear them down each time that you bring them in and service them. It's a little bit more than a Lubin tune.
Right.
Then another thought was, you mentioned problem with the engine failure would potentially eliminate or put everybody in danger. There's some launch vehicles designed with engine out capability.
Right.
That certainly could be built into that vehicle, and you could have either a fully successful transition to lunar orbit, or you could have an emergency landing, which, you know, if it was not at the designated landing spot, would be an interesting problematic.
That's right. but-
Because then, even if you had some propellants there on the moon, 5 kilometers away, unless you would need, think of the infrastructure you would need, the tanker vehicles that were able to transit mobile to get there, hook up, refuel, and it landed with a problem, so it's not going to take off till you fix that problem. So, but certainly your situation is improved with the emergency landing.
Right.
And it's just that you keyed into it when you said there's a lot of infrastructure that needs to get developed for a long-term presence.
And they're not accounting for the mass of all the infrastructure when they say they can build a usable base within the time span they're talking about. Because I submitted last year a long list of all the equipment that NASA would actually need for a minimally robust base. And it sounds to me it would take a minimum of a decade to accumulate that much stuff. And by that time, the first stuff would be worn out.
Mm-hmm.
Okay, there was a question. Did he leave? Go ahead.
Yeah, well, you mentioned about there's been, my name is Mike Locken with the Calgary Space Workers in Calgary. We're building an analog lunar habitat. And on Sunday I'll be talking about some of this as well. I just wanted to bring up I've got about just every single problem that you've mentioned so far, I've got the answer. It's now become a little bit too long to make it as just a simple comment, so you'll have to watch the thing tomorrow, because I'm going to change it a little to answer these questions. But just to give you an idea, number one, to replace piping and wiring, to replace it with brand new stuff in a wall, just to give you an idea, have flex pipe, undo it, put a new one on, pull the old one out, and the new one follows, disconnect, reconnect, okay? You've got a new pipe in the wall. Same thing works for wiring. It's not a matter, and as far as punctures in a habitat, you can make the habitat in layers and have pressure sensors within the wall, so if there is damage, there's an alarm. Thus, it gives you time to go to another room. An automation system working with controls for critical equipment. You can have more than one piece of equipment running in tandem so that there's always one to back up the other. There's various other ways of dealing with all these problems that you mentioned, but that would be a comment as opposed to a question, so I'd have to save it for tomorrow.
Okay, but I appreciate that because, for example, if you have a good trencher piece of equipment like a dead switch in the moon, you could put your tube, bury your tube or multiple tubes in your trench to connect, say, your fuel pipes over to your habitat or over your landing zone. Then you would
have to have a fuel truck to move your fuel from the storage tanks over to your landing zone, because you don't want to land your vehicle right next to your fuel tanks, because if you had a little accident, you might blow up your whole fuel supply. So that's that's just logic. Who else had a question? Larry?
I was just going to make a comment on the person who talked about paper and some sort of overcoat or duster might be part of that you take off in your entryway, might be part of the way of dealing with lunar dust. The particular solution of paper is not a good one for the moon, because on Earth, paper is plentiful and easy to come by and inexpensive. On the moon, it will be very hard to come by and expensive, and it will be a very precious resource to use sparingly.
and it'll be very fragile when exposed to lunar dust, I think. Go ahead.
What's the prospect of, I'm sure you remember 2001: A Space Odyssey. What's the prospect of having a system along that line?
No, it's specific which system.
Like the lunar base and the lunar shuttle.
The huge complicated airlock that opens up and
right.
fingers. Okay, that's something that's probably 50 years after the first lunar base is created. That would require, with today's technology, to build something like that would be $500 billion or something to build something like that with current transportation costs and so on. If we get the transportation costs down and the ability to create structures on the moon, large-scale structures, to dig down to the lunar surface and build large-scale structures in some way comparable to the way we build large-scale concrete structures on the Earth, yes, then we can do that. But we have to develop this technology and the ability to create this lunar infrastructure. We don't know how to do any of this stuff yet. If, for example, if you had concrete on the moon, you'd mine it for its water. There is essentially no water in moon rocks whatsoever. Zero. There is some water in the regolith, but zero in moon rocks.
Because the 2001 scenario was, at one time they knew that after Apollo evolved into it, say after Apollo there would be a lunar base and all that stuff.
Yeah.
So that's the scenario that 2001 was based on.
It would take many steps, many years, especially at the current rate. Now, suppose that the entrepreneurs got going and actually could reduce the cost and increase the safety so you can take tourists to the moon. If that could happen, I don't know if it can. I would love it to happen. If it could happen, the money that would generate would speed up the ability to create this new infrastructure. Because you're going to have tourists, you obviously have to build infrastructure to support them. So that would definitely speed it up. Well, did anybody else like to comment?
I just like to comment that
when you consider the very large structures like that, you have to think that, will it ever be practical to bring
To fabricate those on the Earth and take them to the moon, and I can't come back with no.
I agree.
Okay.
It's a no.
Those
Yes.
type structures will be built when you have the capability to build those large-scale items on the moon itself, both with the people and the machines and the energy all available.
From
So
lunar
those-
materials.
Yes.
From the in-situ materials.
So Wayne,
okay?
what you're basically saying is by the time we get ready to even start building something like that, we'll be building the capital equipment on the moon too. That is
Yeah.
not only
Yeah.
extracting
Yes.
lunar resources, but the mining and processing equipment will be built of lunar resources of, I don't know how many generations it's going to take.
A lot.
Yeah.
So if you think of like the scenario depicted in 2001 is at least 100 years ahead of its time.
Remember, Rome was not built in a day, as everybody's heard that
But
phrase.
having said that, once you've got a couple of cycles going, initial equipment from the Earth, process material on the moon for your base, then you start small, start building small amounts of capital equipment, iterate over a few decades. Eventually, you'll get to a point where it perpetuates itself because the design of your equipment only has to survive one regime, the surface of the moon, rather than design it. Well, as Dennis Wingo in the room, he makes the point that current satellites that have to last 10 or 15 years, the design driver is an environment that they have, the structural design driver is an environment that they're in for 8 minutes. If we can eliminate some of those and make all the capital equipment on the moon, the capability will spiral up and the price will spiral down.
5 minutes. I'd like to make one point there. You know, I think one of the keys for becoming more effective is to put a lot more work in the cascade of production from in situ materials. If we look at solar power satellites or the lunar power system, we're going to need to have large amounts of silicon. If we're fuels and propulsion, we're going to need to have large amounts of oxygen. Now, ilmenite, which is, you know, a lot of ilmenite's present, and it's not going to be that hard to do it, but there's also a lot of meteoritic iron fragments in the regolith. So for us to get supplies of iron and to generate oxygen and to have titanium, we'll have engineering metals, and we can do the same thing with silicon. Then we have at least some of the minimal basic set for life support, solar voltaic arrays, and also the engineering metals we'll need to produce structures for solar collectors and pipes and so forth. One of the interesting things that I think is really going to revolutionize the whole perspective of accessibility and rate of development are these fab machines, these stereolithography. And the real critical issue is, can we develop from lunar resource materials the feedstocks that will allow a fab machine to fabricate all sorts of things? And, you know, those things can be working away, and it's again a suite of robotic, telerobotically operated things that will allow us to produce things from local resources of great diversity and reliability that's going to cut down the transportation budget enormously of stuff that otherwise would have to be hauled up from the gravity well. So, you know, there's a tilting point of technologies that begins with the ability to do demo projects on in situ resource use, and then looking at how we can fabricate things, and all of this relates to cutting down what has to be pulled up out of the Earth's gravity well.
Right.
But a lot of that has to be done. That's some of the really strategic capital investment that I don't see as occurring, and I think there's huge commercial markets for that on Earth, because, you know, we're looking at environmental pressures and our consumables and, you know, and what our vegetative environment is, and we keep stripping that away, and so the ability to use you know, non-living resources that are present in vast quantities. You know, if you look at sand, silicon dioxide, calcium dioxide, all the aluminosilicates and metal oxides, that's what the moon can teach us to do on Earth that can improve our resource base here. So once again, how are we going to make some money? How can we do things that are practical? And what's in it for me? Those are the goals that we have to be relentless about, and where we encourage our research, our young people to research, and our venture capitalists to create a climate where we can do a lot more of that than we're doing.
And remember that energy doesn't weigh anything, but the equipment to transmit the energy weighs something.
Yes.
Well,
I wanted to point out that utilizing the resources on the moon, that's if you can find those resources under all the booster cases that are going to be laying everywhere.
expendable booster cases, right?
Well, then that becomes your resource.
That's your first resource.
Well, we're right about
It has
at
a lot
the,
of
at the end right
interesting
now. I think
materials
it's about a
in there.
minute. On my watch says it's just.
Did
about
anybody
6
else have a
o'clock.
question? Yeah, they're right there. Go ahead.
I think with the new supply of motorcycle, I think we're there. Just dotting the i's and crossing the t's.
Is it sharp and abrasive is the real stuff?
Don't know. I think as far as in situ processing, there's material there you can do easy little experiments with. Little bitty
sacrifice samples, real lunar dust, and put it into a tumbler with another bunch of the new sample, and see how abrasive it is in the tumbler, and see if it really is abrasive as the real dust.
Wednesday, I was in St. Louis, Washington University in St. Louis. I was talking with Paul Carpenter, who's a geologist, pretty knowledgeable about geochemistry. He said, a lot of what we can learn in situ work, it can come by dealing with aspirin-sized tablets of material, where we're doing, we're learning a lot with small amounts of materials, and we can do that. Yeah, so there's a whole ocean of work that's easily capable of being done with small amounts of material. That's a lot. So we need a quantum jump in our knowledge base and our technology base about leveraging those resources. And we're out of time.
Okay, just make a logistical announcement.
Logistics. This room tomorrow and Sunday will continue to be the lunar track, and the transportation of the track will move permanently back into Crystal 6, which is next door, both Saturday and Sunday. I'd like to thank the panel very much. I thought it worked out very well.